So in this example, we're going to look at a two-way table, and we're going to talk about some questions that you might see about that two-way table. So it says each student in a random sample of students at a local high school were categorized according to gender and whether they support a proposal to increase the length of the school day by 30 minutes. The following table summarizes this sample. So we've got male and female, and then our totals, and then we have if they oppose the proposal, support it, or if they don't have an opinion. So some of these questions are going to require us to look at different pieces of the table. It says, what proportion of the students in the sample are male? So if we look at all the students in the sample, the total that we're referring to is 200. So we want to say out of the total of 200, how many are male? So if we go that 200 total that are male are 110. And then if we calculate that percentage, we get 55%. So 55% of all the students surveyed were male. And this is an example of marginal relative frequency because it's taking one of our marginal values and it's finding the relative frequency of. The next question says, what proportion of the students in the sample are male and support the proposal? So of all the students in the sample, I want to know how many are male and they support the proposal. So all the students in the sample, there's 200 students in the sample, and I want to know how many specifically are male, but they support the proposal. So there's 40 of those that are male that support. So that's 40 out of 200, and that percentage is 20%. This one is one of the examples of joint relative frequency because it takes one of our joining values and it creates a relative frequency out of our total. Next, what proportion of the males in the sample support the proposal? So what percentage of the males? So we are looking specifically at the group of males for our total. So we see that there's 110 of those people, and we want to know out of the 110 there are, how many support. So we see that 40 support, and if you calculate that is 36% when you round. And this is an example of conditional frequency because given the condition that they are male, we want to know how many support. What proportion of students in the sample who support the proposal are male? So of the students that actually support the proposal, I want to know how many are male. So if I look at how many support, I see that there are 80 people that support the proposal, and specifically out of these 80, 40 of them are male, which makes 50%. And again, this is a conditional relative frequency because given the condition that they support, 40 are male. Last question says, is there an association with gender and those that support the proposal? So I went ahead and calculated some of the relative frequencies to help me decide if there's an association. So what I did is I said, if we knew that they were male, let's look at how many of those have those opinions if we knew that they were female. So I calculated the relative frequencies out of the rows. And if you look, you can start to see, okay, for those that oppose, very similar. Support, similar. No opinion, similar. So there's not very much difference between if they are male or female and which category they fall in. So there is no association in this data. So our next examples we're going to look at kind of backwards. So if we're given the relative frequency numbers, we want to figure out where that's coming from in the table. So it says interpret the joint relative frequency in the context of the problem if you have 10 out of 200. So we know that it's a joint frequency, so we know it has something to do with these numbers that are joining the ideas together out of our total. So you can see the 200 here and this total of 200. And we want to know that where the number 10 falls. So if you see the 10 is right here. So we can say that out of all the people who were surveyed, there were 10 that were female and they had no opinion. Or if you do the percentage, you could say that that percentage were female and had no opinion. This example says interpret the marginal relative frequency of 30 out of 200. So we know it's marginal, so we know it has something to do with the totals, and it's out of our 200 total. So if we go down here to our 200 total and we say, all right, where is the 30? So I see the 30 is right here. So I know out of all the people that were surveyed, that's how much my total is out of. So out of all the people that were surveyed, 30 of them had no opinion. This one says interpret the conditional frequency in this context. So conditional is given one of the conditions either in the rows or the columns. So I have to look at this total really carefully. So I see out of 110. So if I look at all my totals, I see that 110 110 is this total of males. So out of all the males, I want to figure out where the 50 is, and I see the 50 here. So out of all the males, 50 of them oppose the proposed. This example, I'm looking again at conditional frequency. This time my total is still out of that 110, so still out of the 110, so out of all the males, this time I'm looking specifically at the 20, so the 20 are the ones that had no opinion. So out of all the males surveyed, 20 of them had no opinion. The very last example, we're looking at conditional frequency. Our total is out of 30, so if we look at our categories, I see a 30 right here with no opinion. So out of all the people that have no opinion, I'm looking for the 20, and I see the 20 is here. So out of all the people that have no opinion, 20 of those people were male.